Mark has $100,000 to invest in short-term bond that pays 4%, intermediate-term bond that pays 5%, and long-term bonds that pay 6% in simple interest per year. Mark wished to realize a total annual income of 5.1%, with equal amount invested in short-term and intermediate-term bonds. How much should he invest in each type of bond? There are three types of bonds in this case, so we let X be the amount that Mark invested in the short-term bond. Now, X is not the short-term bond. X is the amount invested in dollars. Y is the amount invested in the intermediate term bond, and Z be the amount invested in the long-term bonds. Remember that the short-term bond only pays 5%, the intermediate term bond pays 5%, and the long-term bond pays 6%. Also, he wished to realize 5.1% in annual income with the equal amount invested in short-term and intermediate term bond. What this means is that the amount invested in the short-term bond X has to be the same as the amount invested in the intermediate term bond. So we have X equals Y. Whatever X is, Y is the same. He has the total of $100,000 to invest. What this means is that if we take X plus Y plus Z, the total has to be $100,000. To realize 5.1% of the annual income, where 4% is being paid to X amount, the interest in the short-term bond is therefore 0.04 times X, simple interest per year. The interest in the intermediate term bond is 0.05 Y, and the interest in the long-term bond is 0.06 Z. We take the percentage of the interest times the amount, and we also need to take 0.051 times $100,000 because he wishes to realize 5.1% of whatever amount that he invested total. Simplifying this, we have three equations. The first equation is X plus Y plus Z equals 100,000. And the second equation is actually X minus Y equals 0. Because if X equals Y, then X minus Y is 0. This gives us one equation. If we want to find the system of three unknowns, then we will need to have three equations. We will use an alternative method when we only need to solve a system of two equations where X equals Y already. So potentially, we only need to have two equations in the system. If we multiply 100 in the third equation, then we have 4x plus 5y plus 6z equals 5, 1, 1, 2, 3, 4. Because 100 times 0.051 is 5.1. 5.1 times 100,000 is 510,000. We now have a system of three equations with three unknowns. We can just simply forget about the word problem and focus on solving this system of equation. But in this particular case, observe that since x equals y, we can rewrite this equation as x plus z equals 100,000. The second equation, where x equals y, we have 0.04x plus 0.04x as well, because y equals x plus 0.06z equals 0.051 times 100,000 is 5,100. We now have a system of two equations and two unknowns only, so we will simplify this. This is 2x plus z equals 100,000 and 0.09x plus 0.06z equals 5,100. We then multiply the second equation by 2 to get an equivalent system of equation. 2x plus z equals 100,000. 9x plus 6z equals 5100, and then we multiply 100. So this is 510,000. We then use either elimination or substitution methods to solve this system of equation because there are only two equations. Using the first equation, we have z equals 100,000 minus 2x, and then we substitute this into the second equation. 9x plus 6, but z is now 100,000 minus 2x. The right hand side of the equal sign is 510,000. This is 9x plus 600,000 minus 12x equals 510,000. 9x minus 12x is negative 3x, and 510,000 minus 600,000 is negative 90,000. So x equals 30,000. If x is 30,000 and x equals y, then y is also 30,000. And then to find z, where z equals 100,000 minus 2 times x, 30,000 for x, we have 100,000 minus 60,000, and so z is 40,000. So Mark should invest $30,000 in the 4% or short-term bond, 30,000 in the 5% or the intermediate term bond, and $40,000 in the long-term bond 6% interest. And this should add up equal to 100,000, where the amount invested in the short term and the intermediate terms are the same.